Let's see question number 27. In a single slit diffraction pattern, the distance between the first minimum on the left and the first minimum on the right is 5 mm. The screen on which the diffraction pattern is displayed. Okay, as it is the distance of 18 centimeter from the slit, the wavelength is 600 mm. The slit width in mm is about. So this is the simple formula based question. We have to put the formula. Okay, we know the width is what we have to find. Slit width. Slit width is d lambda, capital D lambda by small d. Here, here data is given capital D. If we go for the capital D, so what is the okay? So if the screen on which the diffraction pattern is displayed is at distance of 80 centimeter, okay? So capital D is given 80 centimeter. We have to calculate in mm. So 80 centimeter is given. So first we will calculate in meter, then we will calculate 80 into 10 to the power minus 2 meter. Okay, this is the value of D, and the lambda is also given. Uh, Lambda is given. What is that lambda? Lambda is 6,000. Lambda is 6,000 angstrom. Okay, so we can convert it in meter also. So we are just converting it in meter here only into 10 to the power 10 meter. So you have got the lambda, we have got the this, and what is given? Left the first minimum on the right is 5 mm. Okay, distance between the first minimum on the left and the first minimum on the right is 5 mm. Okay, so what would be the D basically? So D would be simply 5 by 2, because it's 5 mm is given, so we can convert it into centimeter, 10 to the power minus 3 meter. Okay, now whole things are in same unit. Now we can put the value, and by solving this we can get the result of the width, that is 0.192. 0.192 into 10 to the power minus 3 meter. Okay, we have to convert in mm. So 10 to the power 3 mm. So 0.192 mm. So option C is the correct option. Now we should take the case of the question number 28. What is question number 28? Question number 28 is the angular width of the central maxima in a Fraunhofer's diffraction pattern is measured. Slit is illuminated by the light of the wavelength 6,000 angstrom. If the slit is illuminated by light of another wavelength, okay, angular width increased by 30% wavelength, and light used is, then wavelength of light used it. Obviously, we have to compare the two wavelength, and we can get the result. Okay, so let's see. So In case of problem number 28, so we can say that we have to find the angular width. Okay, so what is the angular width here? So angular width uh, can be given as theta. Suppose it can be given as theta. So theta is equal to what we can write the theta? Theta is equal to, having the formula, theta is equal to lambda by A. Okay, where A is the distance between slit width, basically width of the slit. Okay, now we have to find uh, angular width. Okay, so simply if we will see lambda, or we can say theta is directly proportional to lambda. Okay, so theta 1, if we are considering theta 1 after change, is equal to lambda 1, or theta is equal to lambda first. Now if we'll calculate, if we'll get the ratio, we can put theta 1 by theta is equal to lambda 1 by lambda. Now we have to find the lambda 1. Okay, so lambda 1 can be written as theta 1 lambda by theta. Now what is theta 1? Okay, that is the that is the basically 30%. Angle is decreased by 30%. So if it is decreased by 30%, so we can say that it is a 0.7, means 100% minus 30 is good, means 0.7. Can we write it? 0.7 means, if we will now, let's see here, 30 divided by 100. What we are getting? We are getting del theta by theta. Okay, that is the change. So change would be 0.3. Okay, that is the 0.3. That is the decreased change. So zero point 0.3 will be changed. So remaining will be 0.7. Okay, so can we put the ratio of this theta, mu theta divided by previous theta, that is the 0.7 by 1. Okay, so can we write 6000 is the value of the lambda, and theta 1 by theta, this is the 0.7. Okay, if you multiply this, you will get the 4200 angstrom. So option B is the correct option. So what we did, we have just taken the concept of theta is equal to lambda by A, where A is the slit width. Okay, and we are knowing that theta is equal to is directly proportional to lambda. So initially it was 1. So if we will take the ratio of and after if 30% is less, so that is the 0.7, the value of the theta, new theta. Okay, new theta means the angular width. The value of the angular width is 0.7. So theta dash by theta can be written as the 0.7 by 0.1. So by putting this value all the value, we have got the result. 28 is the uh, 4200 is the correct answer for this. Okay, let's see question number 29. Which of the following phenomena is not common to the sound and light wave? Okay, interference. Obviously, interference comes in sound as well. Light wave. Diffraction is also. Reflection also happen. So only option polarization. Polarization is only option that is not common in sound wave and light wave. It only happens in light wave. Okay. Now see the question number 30. A wave front of the represented by the y is equal to 3 minus x. The propagation of wave as propagation of waves takes place as uh, wave front of the wave has direction with wave motion. Oh, perpendicular direction with the wave motion. It is the perpendicular the direction of the wave motion. Okay, that is the wave front is always perpendicular to the direction of the wave motion. Okay, Huygens principle is secondary wavelets may be used to. Option is find the velocity of the light in the vacuum, explain the particle behavior of the light, then find the new position of find the new position of the wavefront, explain the photoelectric. Obviously, Huygens principle is based on the position of wavefront. Okay, secondary wavelet because in secondary wavelet may be used to the new position of the wavefront because as we know that the secondary wavefront is uh, uh, wavelets is acts as in the source for the further wavefront. Assessment and reasoning. Question number 33. The clouds in a sky generally appears to be whitish. Okay, the sky generally appear to be whitish. Obviously, reason is given diffraction due to clouds diffraction. The clouds of efficient. Okay, clouds is diffraction due to cloud is efficient in equal measure of all wavelengths. Obviously, diffraction due to diffraction, we are seeing the cloud as a whitish, and the wavelength is equal measure in all wavelength. Okay, so diffraction is whatever diffraction is occurring, that is the equal level of all the wavelength. So I think both assertion and reason are correct. Okay, of the diffraction band. Okay, diffraction band varies. The wavelength directly at the width of the slit, directly at the distance between the slit and the screen. Inversely, as the size of the source from which the slit illuminated. Okay, means what? Wave as because it passes from the very small slit, means a small opening. Okay, as a small opening, if size of the source will increase, the width diffraction will decrease. Okay, width of the diffraction will decrease. Diffraction occurs when the high illuminated light is passing through a small width of slit. Okay, that we have given Young's single slit experiment. Okay, so if the even if the width will increase, okay, if the width will increase, obviously the the diffraction band, the pattern which we are getting brighter and dark pattern, the fringes will also decrease. So it is an inversely proportional as the size of the source from which the it's illuminated. Okay. Question number 35. In a single slit diffraction experiment, the width of the slit is made double its original width. Then the central maximum of the diffraction pattern will become, obviously it is going to be narrower. Okay, central pattern, because if the width will increase, the uh, pattern would be narrower. Okay, because if we are going to increase